And of course, I'm already noticing a typo. Typical. Unions. All right, so we're going to talk about probability today. I was going to do 2 sections in one day, but with our class being cut short, we'll just knock out one today, one tomorrow, and one Thursday, review Friday, and Monday in this particular class, which we should be fine for that. So we are going to determine a sample space. We're going to just calculate basic probability. A lot of times y'all are perfectly fine with this stuff. Use a lot of common sense, and it's pretty straightforward and easy for y'all, okay? I have a tendency of making it harder than it actually is or needs to be. So what is probability? I think do I have it where it appears? Come on. I guess I don't. All right, so good thing I have it here. All right, so probability measures how likely it is for an event to occur. Okay, it measures how likely it is for an event to occur. You asked me the probability of us having a snow day today, or a 2-hour delay, I would have said a 0% chance, but who knew that was going to pop up? And I'm not mad about it. Because like, it's amazing what I can get done in 3 hours. Yeah. It's crazy.
I made Eggo.
You made what?
You know, we learned.
I made strudels.
We learned 11 golden facts about Eggo waffles yesterday. If you they would be glad to share with you.
All right, guys, we don't need our Chromebook right now. All right, so probability. It's the number of outcomes with event A over the amount of outcomes with our sample space, okay? That's why when you're rolling a dice, okay, and we can say that it is a 1 in 6 chance I'll roll a 2. Okay, there's a 2 on there once. We have 6 chances, 1, 2, 3, 4, 5, 6. Okay. We talked about sample space already. It is the set of all possible outcomes. So if I'm wanting to know the probability of maybe 2 students in here making 100 on the test, then I would count up how many students are in here and put 2 over that. An event is a collection of outcomes from some chance, and the process when we're dealing with, I think that cut off there. It did. Usually they like to say it's a capital letter. So I like to say event A, event B, event C, and so on. Okay. So one of the important things that we need to look at is independent versus dependent events. Okay. An independent event, event A, has no effect on event B. Okay. So for example, if I want to know the probability of, let's see, I do the dependent one a lot better. Probability of, that gets me into multiple events. Hold on. The probability of me rolling a dice and flipping a coin. Okay. So the probability of me rolling a dice and getting a 2 and flipping a coin and getting a heads, they don't really go hand in hand. However, If I am looking at a dependent event, it does affect it. So maybe I say, what's the probability of drawing a 4 of hearts or something like that, okay? Those two go hand in hand. Or an even number and a hearts card, okay? And we'll go over cards and stuff like that because, again, I assume that everyone knows cards in general, but then a lot of people don't. So I have to make sure that we go over. I would hate for you not to be able to know what the actual possible outcomes are because you're just not familiar with something. Okay?
It's a 1 in 52 chance.
Mm-hmm.
Don't worry, Dayton. Got your back.
Thanks, Emma.
All right. So like I said, independent and dependent events are definitely something that could pop up on a test. And it can ask you for anything of that nature of like a scenario and say, what's the independent? Is this independent or is this dependent? I think that's exactly how it asks you in your homework. Okay. So this would have been relevant, I guess, last week. But it definitely works for this as well. So you can have different organized ways of trying to figure out the probability. Okay. So if I'm asking you, what are the possible outcomes if you have 2 children? Okay. So you can use a table. What if I have a girl and a girl, then I have a girl and a boy, or a boy then a girl, then a boy and a boy? Okay. So then you can actually use a table to show a way of looking at all your different outcomes. Okay. You can use a tree. I think you use that a lot for like shirts and pants. Probably back in the good old days of probability where they're like, what's the different outcomes if you have 3 shirts and 4 pairs of pants or something like that, and then you kind of drew a tree out from there. So if there's a girl, I can have a girl or a boy, and if there's a boy, I can have a girl or a boy there as well. Okay, so a tree helps, or you can just make an organized list. All right, so that's 3 different ways that if you're trying to figure out outcomes, you can use to help you figure this stuff out. A lot of times I like to draw pictures with these because for me as a visual learner, if I actually write out or draw something, then I can actually count out what's happening, which can get really annoying, especially ones that have like higher outcomes. Okay. All right. So, things you need to know. This is what I was talking about, okay? How many sides are on a die, okay? So, we know a dice to have 6 sides, okay? 1 through 6. And again, some of y'all might be like, I'm going over this. I literally had students that were like, I've never seen an actual dice and I've never played cards, so I don't know all these different things, okay? So that's why I always go over them so you know your outcomes, okay? So what are the chances of rolling a 5 on a dice? What?
1 in 6.
Okay. So there's a 1 in 6 chance that we actually get a 5. Now, if we can up it and we can say something like what's the probability of getting an even number? So now I do 2, 4, and 6. That's 3 out of 6. That's a 1/2 chance. Okay. So different things like that. All right. How many cards are in a deck? 52. Okay. So some of us might not know that. Okay. Some of us might not know there's clubs, spades, hearts, and diamonds. Okay. There's also what they call face cards. There's literally a face on it. So your Jack, Queen, King are your face cards. Okay. Ace, that's always your tricky one. Okay. Sometimes ace is in the front, sometimes ace is in the back. Ace is high, ace is low, whatever. Okay. So you got to make sure you're paying attention to that. If they have it set up this way, again, if they have this set up like this anyways for you, be very thankful, because if we are wanting to know the probability of pulling an ace out of the deck, I can literally look straight here and say, oh, there's 4 out of 52. I can reduce it from there. Okay. But a lot of times it's hard to visually see that. It's also nice when you can have that out on display for you when they ask the question, what's the probability of getting an even number out of the deck? So that I could go through and I can actually count my cards. Okay, so that's not always going to be given to you though. Just so you know that. Okay. And a coin, I hope y'all know, is two-sided. You got your heads, you got your tails. Just making sure. Okay, of the 60 vehicles in a teacher parking lot today, if there's even 60 out there, 15 are pickup trucks. What's the experimental probability that a vehicle in the lot is a pickup truck? Go ahead and figure that out on your notes. All right, so if there are 15 out of the 60 we have, that should get us a 25% probability that it's a pickup truck. Okay, 1/4. So this is the type of probability I can get behind. Okay, yeah.
Are we always going to convert to percentage?
Are you all what?
Always going to convert to percentage?
Not always. If it's a multiple choice test, follow what they do if they have answers written as fractions. More than likely, if it's written as a fraction, it's a reduced fraction. So you would put 1/4 chance. In some cases, you might give the decimal, but don't give the decimal with the percentage. Actually convert it to a percentage. Okay? Try this one. schedule written down. I need to make sure I do that. All right. So we are looking at a glass jar, 1 red, 3 green, 2 blue, and 4 yellow marbles. If a single marble is chosen at random from the jar, what's the probability of it being blue? Who has it for me? Yeah, go ahead.
20%.
20%? How'd you set that
Well, there's 10 marbles total,
up? Okay.
and there's 2 blue in there, so it's 2 over 10, and that's 1/5, and that's 20%.
Okay, good. Okay, so like I said, this is the probability I can get behind. This is the good stuff. This is the old school stuff. Okay? Any questions so far? Okay. So now we're going to look at a couple of multiple events that can happen. Okay? So, without me going over anything before, go ahead and see if you can figure these questions out. What's the probability of rolling a 5 and a 6? Probability of not rolling a 5, and the probability of rolling a 5 or a 6. You have a question?
Yes. For the first question, is it 1 dice or 2?
Welcome to probability. If they don't specify it inside there, assume 1. Or assume 2. Or assume 3. We don't know.
Oh.
This is when I have issues with probability, because if they don't word it exactly, then you're left to guess. I don't like to guess in math.
My favorite part.
If it works for you.
It doesn't. I'm not good at it.
Does that mean does the first one mean at the same time?
Yeah, having both.
Not at the same time.
Okay.
Oh,
So if you had 2 dice, it'd be rolling them at the same time. What's the probability?
So we're assuming there's 2 die.
Do it.
We're assuming there's 2 die. Okay, because if it's 1, it's
Impossible.
yeah.
Right.
Okay. Anyway.
This is literally a question that I grabbed from something. So this is how
Well, I mean, it's not.
bland they can be presented.
Let's see.
It looks stupid because it's like you use 3 mouths when you do that. It's like you use 3 mouths when you do that. So you got this one and then this one and then you actually. It looks like a lot of important.
Okay. So there's some really big key words in a lot of these questions. Okay. It's as simple as saying and or. Or just say one without the other.
And or.
Okay. And or. are literally going to help you decide between what formula to use. Okay? So it is the probability of something happening and another thing happening, or something happening or something happening. Okay, so that's two totally different things. Okay? So without me teaching you anything, what is the probability of rolling a 5 and a 6? Dylan?
136.
136 chance. How did you get that?
So if you have a 1 in 6 chance on each dice to roll that number, then you would multiply the two together to get your.
How did you decide you were multiplying?
Because, well, if you. I don't know how to explain it. It's like,
What else would you do?
yeah.
Add.
I did, but like, why would you
Oh, well,
actually?
you wouldn't add it because they're not, that'd be the or situation.
Jonah?
I got a 1 in 18 or a 2 in 36 chance.
1/18 or 2 and 36. So how'd you get that?
I made a table of, so there's 6 for each, and then there's 2 spots on there where there's a 5 and a 6. That's 2 and 36, and simplify it to 1/18.
Okay. So that would be if we were in the situation of the 2 die, right?
Yeah.
Okay. What is the probability of not rolling a 5? Who got that one? One besides Kevin and Dylan. Not rolling a 5. What's our probability on that one dice?
5, 6,
5 and 6. Why'd you get 5 and 6?
because 1 7 is 5 on.
Okay. So if there's 6 total, I just want to roll the dice once. I assume that I'm only allowed to roll it once. Okay. I roll it once, and I have a 5 and 6 chance of not rolling a 5. Okay. What's the probability of rolling a 5 or a 6? Yeah?
Is it 11?
Not 11 over 6. Okay.
Is it 1/3?
One what?
Is it 1/3? Is it 2 over 6?
So how'd you set that up?
Well, I mean, it's asking for 2 possible outcomes. So
Uh-huh.
there's 6 total, so then since it's or, you don't have to roll them, so it can be one or the other. Which
Okay.
means you can put them on the same bracket.
So 2, 6, which gets me a 1/3 chance.
I guess.
Okay. You know how you said, why would we ever add it?
Yeah.
You just did.
Well, yeah, but I know at the end.
Would you just add one on top as well? The first question?
Do what?
Wouldn't you just add the first question as well? Because if you're rolling 2 die, then there's a possible outcome of 12 different outcomes, right? Because you have 6 in one die and 6 on the other, so it'd be 2 over 12. And then
If we were rolling.
that's what I'm saying.
Right.
'Cause
That's when it becomes one of those issues of, I would hope that they would specify for y'all on a state test. Like I said, if not, assume 1. All right. But if they start throwing in multiple dice, or die, I guess is the plural of that, then I guess I would say that you would have to include both of them. So I haven't taught you anything about formulas whatsoever. Okay, so the multiple events happening is exactly that. When we have an and problem, we're multiplying. When we have an or problem, We're adding, okay? So you're gonna see them write these in a weird way. I think it's a couple of slides from here. I'll talk about those in a second. Right here. We're not there yet, sorry. Let me just put it next to it. So if we have the probability, and this is how they're gonna write it, of one event happening, probability of A and B happening, then we are gonna do the probability of A times the probability of B, okay? But if we're looking at, and this is where it gets, there's actually two formulas for this one, but probability of A or B happening, then we're going to do the probability of A plus the probability of B happening, okay? And like I said, there's going to be two for those, and that's why I said it was a little too much that I'd gone on the last slide, okay? All right. So do you notice how I tried to have y'all answer these problems without knowing anything? A lot of times, and I've been very tempted with the probability stuff just to say, go for it, okay? And I don't like to say that because I like to actually teach you it, but I feel like y'all have enough in your like common sense minds to do a lot of probability problems without like learning all the muddy water stuff. Meaning like formulas and stuff like that, okay? Y'all were able to at least talk through and reason through these three problems without knowing anything, okay? You don't even have to know about the probability of A and B happening or the probability of A or B happening. You were just like, well, if I do this and I do this, that's my chance, and voila, there's my answer, okay? So hold on to that when you take an actual state test, or remember, we're not testing over probability and statistics as a chapter test. So just kind of remember those things, visualize and everything as well, okay? So I just want to show you these two symbols real quick. You have what's called an intersection. It's an upside down U. So you could possibly see that, and that's why I'm putting that on here. Instead of them saying the probability of A and B happening, they're just going to write it as A with the upside down U and a B, okay? Intersection is your and problems. A and B are happening at the same time, okay? Then you have your or problems, which is called a union. A or B can happen. Okay, so that opens up a lot more for us. And then we have what's called the complement, which again will be the not, okay? When they're like, it is not an A or B, okay? That's when we'll look at those. But I wanted to give y'all a visual representation. I used to teach where we would have like sets of numbers inside the Venn diagrams, and you would have to figure out which one you would find the probability within those Venn diagrams, and they had my head spinning. So
Sounds
yeah,
overly complicated.
yeah.
Yeah, I don't understand anything you just said.
You don't what?
I don't understand anything you just said.
Like today?
No, I understand that stuff, but I don't understand like what you mean about the Venn diagram.
Oh, I was like, when the student says, I don't understand anything you said, really just opens up the ball game there.
Which kind of help us with grade.
Like it would be, like they would put numbers in the Venn diagram, and they could ask you the question, probability of A and B happening, which in this case you would just say 4 and 5, because it would be those in that middle piece there. But then it starts getting into the probability of it being an A and, oops, as I write an A and B, but how would they write it? I can't remember how they wrote it. They could say the probability of it being an A and B and not B. And then they start saying like it could be in A or B, but not. And so they start throwing in a lot of stuff. That's what I said. I used to do a lot of Venn diagrams, and it would have my head spinning just as much as the students. So I was like, we're just gonna call it on that.
Fun.
Yeah. A lot of the intersection, like the A with the U upside down and then the union with it up, was a lot of stuff we used in college for proofs and stuff like that, because they're talking about sets like crazy.
Yay.
So again, that's another visual representation. So what we're going to do tomorrow, which is the second part, is the multiple events. And that's when we start talking about whether something is mutually exclusive or not. Okay. So again, this is part 2. That's why I said I was going to combine both of them in one day. And then since we have a shorter class period, go ahead and get started.